A quantity having both magnitude and direction is called a vector quantity. If you get the magnitude length as 0, then also it is called as a zero vector or a null vector. The unit vector along the vector A is A cap is equal to vector A divided by its own length. Just the coefficients of I, J and K must be added or subtracted to get the sum or the difference A plus B and A minus B. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now in this session I am going to discuss regarding very important chapter and very easiest chapter, that is vector algebra. Vectors, this is very easy and important chapter. Now let us come to the weightage. What is the weightage for this chapter? Vectors. The weightage, so it contains one mark question. Usually they will ask one definition of vectors or types of vectors. So you will get 1 mark question from types of vectors or definition, and there are two mark questions. So one is from dot product, another one is from the cross product, whereas 3 mark questions. So it is also from dot product, that is scalar product, or the cross product or vector product. So one mark question, two marks questions, and 3 2 marks question. Totally the weightage for this is 11 marks. So there is no 5 marks question or 6 marks question or 4 marks question. Only 1 marker, 2 marker and 3 marker questions you are going to expect from this vector chapter. And this is very important chapter. Once if you know all the concepts in vectors, then it is easy for you to solve the problems in the next chapter, that is 3D geometry. 3-dimensional geometry. It's very easy. Everything depends upon the vector algebra. Okay, let us discuss regarding the vectors first. So in this session I am going to discuss regarding the definition of a vector, the types of vectors, and the operations on vectors like addition and subtraction, the addition and difference of 2 vectors, and the scalar multiplication of 2 vectors. Then you have vector multiplication, that is called as the cross product, and the problems based on the cross product, finding the area of a triangle, or finding the projection, or finding the volume of a parallelepiped, and then finding the area of a trapezium or a quadrilateral using vector method. So these are the things which we are going to study in this chapter. Now today I am going to discuss regarding the definition and the types of vectors. Now you know what is a vector. A quantity having both magnitude and direction is called a vector quantity. Magnitude here refers to the length. A quantity having length is nothing but the magnitude, and the direction is called the vector quantity. Magnitude is nothing but the length. A quantity having both length and the direction is called a vector quantity. Example for vector quantities are velocity, force, acceleration, etc. These are all vector quantities. Velocity, then force, and the acceleration. These are all the examples for vector quantity. That means having both magnitude as well as the direction. Whereas a vector is represented by a direct line segment. A vector is represented by a direct line segment, and the arrow mark indicates the direction of the vector. This is the representation of a vector, vector AB. The arrow mark indicates the direction of the vector from A to B. This is vector A or AB. So vector AB, the direction indicates the vector is from A to B. This can also be represented as vector A, small a. Now here, this is the vector A. A is called the initial point and B is called the terminal point. So the vector AB is denoted as vector AB is equal to vector A. A is called the initial point and B is called the terminal point or terminal position, initial position or a terminal position of the vector. And this mod of AB is nothing but the length of vector AB. So a quantity having both magnitude and direction is called a vector quantity. A vector is represented by a direct line segment, and the arrow mark indicates the direction of the vector is from A to B. The mod of AB is nothing but, mod of A is nothing but the length or the magnitude of the vector. Now, the opposite of a vector quantity is called a scalar quantity. A quantity having only magnitude but not direction. A quantity having only magnitude but not direction is called a scalar quantity. But not direction is called a scalar quantity. A quantity having only magnitude. It has a magnitude, length, but not particular direction. So examples: length, mass, time. These are all examples for scalar quantities. Okay. Few more examples are speed, density, and even volume also. Right. These are all examples for a scalar quantity. So, few examples for scalar quantities are length, mass, time, speed, density, volume. These are all examples for a scalar quantities. Now, let us know regarding the position vector. This is very important. Position vector PV, the position vector of the point P, X, Y, Z be any point in the space, then this OP is called the position vector of the point with respect to the origin O0, 0, 0. So, the magnitude of the OP is given by the magnitude of vector R is equal to root of x square plus y square plus z square is called the magnitude of the vector AB. The position vector of x, y, z, then OP is called the position vector. So, if I, j, k are unit vectors, then if I, j and k are unit vectors, then the position vector is denoted by the position vector of P's OP vector is equal to vector x into I plus y into j plus z into k. That I will explain in the next concept. Okay. Now, see here. The position vector of the point A, B, C with respect to the origin O is denoted as, this is the point x, y, z. The position vector of this point is given by vector A along OA, vector B along OB, and vector C along OC. So, that is denoted as OA is equal to vector A, OB is equal to vector B, and OC is equal to vector C. These are the position vectors of the point O with respect to A, O. So, the position vector of the point A, B, C with respect to the origin O is denoted as vector A is equal to OA, vector OA is vector A, and vector OB is equal to vector B small b, and vector OC is equal to vector. So, A, B, C are the position vectors of the point P, X, Y, Z with respect to the origin. Okay. Now, let us come to the types of vectors. There are different types of vectors. In this, you are going to study only few types of vectors. That is, the first one is the zero vector or a null vector. A vector whose initial point and the terminal point coincides is called a zero vector or a null vector denoted as 0. So, a vector whose initial point as well as the terminal point coincides is called a zero vector. For example, A into A, B into B. For this vector, the initial point and the terminal point are same. The initial and terminal point coincides, then the vector is called a null vector, or a vector whose magnitude is 0. If you get the magnitude length as 0, then also it is called as a zero vector or a null vector. So, a vector whose initial and terminal points coincides is called a zero vector or a null vector denoted as vector 0. This is zero vector, where A into A vector and B into B vector, the initial and terminal points are same. Therefore, this is a null vector because the length is 0. Or you can also define a vector whose magnitude is 0, whose length is 0 is called as a null vector. Now, the second type of vector is a unit vector. Unit means 1. A vector whose magnitude is unity, 1 unit. A vector whose magnitude is 1 unit is called a unit vector. A unit vector is usually denoted by A cap. A cap. This A cap is nothing but the unit vector A. Vector A cap is called the unit vector. That means a vector having only unit magnitude, a vector having the magnitude as unity is called a unit vector, and it is denoted as vector A cap. Now, the third type of vector is co-initial vector. Co-initial vectors, two or more vectors having the same initial point. are called co-initial vectors. Here this is the initial point, this is the initial point, O is the initial point for vector A, for vector B and vector C. So O is the initial point for these three vectors OA, OB and OC. Therefore these are called as the co-initial vectors. So vectors having the same initial point. Suppose if there are two vectors, say this is OP and OQ. These are also the co-initial vector OP and OQ. So for these two vectors, the initial point is same, but the terminal point is different. So two or more vectors having the same initial point are called as the co-initial vectors. Here OA, OB, OC are co-initial vectors. OP and OQ are a co-initial vector. So here vector OA, vector OB and vector OC are co-initial vectors. Now let us come to the next fourth one, collinear vectors. Collinears. Two or more vectors are said to be collinear if they are parallel to the same line. If they are parallel to the same line, then they are called as a collinear vectors. For example, let us consider these two vectors, vector A, B and this is another point P. So then vector AP and BP. So APB are a collinear. Here vector AP and BP are a collinear. So that means two or more vectors are said to be collinear if they are parallel to the same line. Here APB are collinear, lies on the same line. Now equal vectors. Equal vectors. Two vectors are said to be equal. Vector A and B are said to be equal if and only if they have the same magnitude and direction. Vectors having same magnitude and directions are called as the equal vectors. Let us consider these two vectors, vector A and vector B. Let us consider two vectors A and B are said to be equal if and only if the length of A is equal to length of B. Then only we will call two vectors are said to be equal. Equal vectors. Two vectors are said to be equal. A and B are two vectors are said to be equal if they have same magnitude and the direction. The magnitude, length as well as the direction. So two vectors are said to be, these are the two vectors, vector A and vector B. These two vectors are said to be equal if and only if the length of, this is vector AB and this is vector PQ. Vector AB length is equal to length of vector PQ. Then only you can say that vector AB is equal to vector PQ. So if two vectors having the same magnitude and the same direction, then the two vectors are said to be equal, denoted as vector A is equal to vector B. Okay. Now, let us come to the very important concept, negative of a vector. This is very important definition. They may ask in the examination, define negative of a vector for 1 mark. So, negative means a vector whose direction is opposite to that of the given vector. A vector whose magnitude is same as that of the given vector, but the direction is opposite to that of it is called the negative of a vector. A vector having the same magnitude but opposite direction as that of the given vector is called the negative of a vector. So a vector whose magnitude is same as that of the given vector but the direction is opposite to that of the given vector is called as the negative of the vector, denoted as minus A. Suppose the negative of the vector AB is BA and that is denoted as BA is equal to minus of AB. Here A to B is a vector, this is vector A and the negative of this is minus A, the direction is from B to A. So BA is equal to minus AB, whereas the length is same, the length of AB is same as that of is also equal to length of BA because negative mod of A is also equal to positive. So the length is same but the direction is opposite is called the negative of a vector. That is, a vector whose magnitude is same but the direction is opposite to that of a given vector is called the negative of a vector and it is denoted as vector BA is equal to minus of vector AB. Now, let us come to the addition, that is the operations on vectors. Here we are going to study addition of vectors, subtraction of vector, scalar multiplication and vector multiplication. So here first let us know regarding the addition of vectors. So you might have been studied in your previous classes, addition of vectors can be done by well-known law, that is called a law of parallelogram of forces or addition law of triangles, converse law of triangle or addition law of triangles or law of parallelogram of forces that you might have been studied in your previous classes. Now let us consider the two vectors, vector A and vector B. Suppose this is vector A and this is vector B. AB is vector A and AC is equal to vector B. Then how to add these two vectors? So if you add this vector, so vector A plus vector B, that is vector A plus vector B. Vector A plus vector, this is AB is vector A, and what is AB? Vector A, and vector BC, BC is equal to vector B. Then the resultant AC will give the sum of these two vectors, vector A and vector B. So AB is equal to vector A, BC is equal to vector B. Then the resultant of these two vectors, vector AC is equal to vector vector AB plus vector BC, that is nothing but vector, suppose if this is vector R, this can be written as vector R is equal to vector A plus B. This is called the addition of vectors. So A vector AB plus BC is equal to AB, that is called the addition of vectors. Now this can also be done using a well-known law, that is called the law of parallelogram of vectors. So what is this law of parallelogram of vectors? Suppose if two vectors are acting, if two vectors, vector OA and vector OB, or vector A and vector B are acting along the adjacent sides of a parallelogram, then the diagonal passing through them will give the resultant of these two vectors, vector A and vector B. Now let us consider two vectors, vector OA and vector OB. Then the resultant of these two vectors is given by vector OC is equal to vector A plus B. So OA is equal to vector A and AB, vector AC is equal to vector B. Then draw this vector R is equal to vector OA plus AC is equal to R, or you can also write vector OB plus BC is also equal to vector R. So vector R is equal to A plus B, OC is equal to OA plus AB. Suppose if OA is equal to vector A and OB is equal to vector B, then vector OC is equal to R, that is equal to A plus C. OC is equal to OA plus OB, OA plus OB or AC, this is equal to vector R is equal to vector A plus B. OC is equal to vector OC can also be written as OA plus OB, that is equal to vector R plus A. Or if we consider this triangle, vector OA plus AC is equal to vector R. So since what are the properties? The addition of vectors is commutative. Vector A plus B is also equal to B plus A. The addition of vectors is commutative. Commutative law holds good in case of addition of vectors. Even in case of addition of vectors, the associative law also holds good. Vector A plus B plus C is also equal to vector A plus B plus C. So addition of vectors is commutative, that is vector A plus B is also equal to B plus A, and addition of vectors also satisfies the commutative law, that is vector A plus B plus C is also equal to vector A plus B plus C. This is called the associative law, a commutative law and associative law. So addition of associative law and commutative law holds good in case of addition of vectors. So this is known as the law of parallelogram of vectors, that is addition of vectors can be done by well-known law, that is called the law of parallelogram of forces. Suppose if two vectors are acting along the adjacent sides of a parallelogram OA and OB, then the diagonal passing through will give the resultant of these two vectors, vector A plus vector B is equal to vector R, vector OA plus OB is equal to vector OC, or even if we consider only this part, the triangle, triangular law can also be applied as vector A plus vector B is equal to vector of A plus B is equal to R. That is regarding the addition of vectors. Okay. Now let us come to the next, the very important definition. They may ask in the examination, define a unit vector. As I told, unit vector is nothing but a vector whose magnitude is unity. So the unit vector in the direction of vector A. Now definition of unit vector is a vector whose magnitude is unity is called a unit vector. Whereas the unit vector in the direction of vector A is defined like this. If A is a vector, the unit vector along the direction of vector A is denoted as A cap. This is A cap, and is given by A cap is equal to vector A divided by its own length. This is the length of vector A. So, if A cap, the unit vector along A is given by vector A divided by its own length is called the unit vector. That is, A cap is equal to vector A divided by length of vector A. So, or if you want to find the vector A cap, a unit vector into its own length will gives the given vector. If you cross multiply. So, here, suppose if AB is a vector, this is the vector A, then this part is called the unit vector. The unit vector A cap is given by vector A divided by its own length is called the unit vector. This part is called the unit vector having unit magnitude. So the unit magnitude is A cap vector A cap unit vector is vector A divided by its own length. So a unit vector along the vector A is given by vector A cap is equal to vector A divided by its own length is called the unit vector. This is very important. In the examination they may ask, find the unit vector along the direction of vector A. I will do that problem in the next session. Now, what is unit vector? Vector A divided by its unit vector along vector A. Definition of unit vector is a vector whose magnitude is unity is called a unit vector. And what is unit vector along vector A? The unit vector along the vector A is A cap is equal to vector A divided by its own length. Now, let us come to the components of the vectors. This is very important. The components of the vectors as well as the position vector. Now, suppose if OA, OB and OC are unit vectors, each length is equal to 1. The length of OA is equal to 1, length of OB is equal to 1 and length of OC is equal to 1. Then having the unit vectors of magnitude along OX, OY and OZ axis. So, these are the unit vectors. OX, A is equal to the coordinates of A 1, 0, 0. This is along X axis, and OB, this is B 0, 1, 0 along the Y axis, and OC, that is 0, 0, 1 along the Z. So here X is 1, Y and Z are zeros. Here X is 0, Y is 1 and Z is 0. Along the Z axis, X and Y are 0, Z is equal to 1. This is unit vector along I. This is unit vector along J, that is I is a unit vector along X axis and J is a unit vector along Y axis, and K cap is a unit vector along the Z axis. Then the unit vectors having the magnitude 1 along X, Y and Z axis are OX, OY and OZ axis are denoted as I cap, J cap and Z cap. I cap is a unit vector along X axis, J cap is a unit vector along Y axis, and Z cap is a unit vector, K cap is a unit vector along Z axis. So therefore the position vector of this point P X, Y, Z is given by vector OP is equal to Xi plus Yj plus Zk. The position vector of the point P is given by Xi plus Yj plus Zk. Suppose if it is only X coordinate and Y coordinate, then the position vector is given by Xi plus Yj. If we put the magnitude for this, that is called the length of OP. So this is very, very important concept. The position vector of the point P, X, Y, Z along X, Y and Z axis is given by the vector OP is equal to Xi plus Yj plus Zk. Similarly, the position vector of the point P X comma Y is given by vector OP is equal to Xi plus Yj. This is regarding the position. So, I cap along X axis, J cap along Y axis, Z cap along Z axis, K cap along Z axis. So, along X axis 1, 0, 0, along Y axis 0, 1, 0, along Z axis 0, 0, 1 are the coordinates. So, I cap, J cap and K cap are the unit vectors along X axis, Y axis and Z axis. Therefore, the position vector of the point P, X, Y, Z is given by vector OP is equal to xi plus yj plus zk. Hope you followed this. Now let us come to the next. The position vector of the point OP x comma y is given by OP is equal to xi plus yj, whereas the length of OP is given by the magnitude of OP is given by magnitude of xi plus yj is nothing but square root of coefficient of I, j and k square, I square, I coefficient of I, that is x square plus y square, j coefficient. So the magnitude of this OP is given by the length OP is equal to root of x square plus y square. In case of the position vector x, y and z, OP is equal to x, y, z, P is equal to x comma y comma z. Then the position vector OP is given by xi plus yj plus zk. The length of OP is equal to length of OP is square root of x square plus y square plus z square. The length of this is mod of this is root of x square plus y square plus z square. If A and B are any two vectors, then A position vector is denoted as a1i plus a2j plus a3k. For the vector B, we can also write b1i plus b2j plus b3k. Suppose if C is any vector, then this can also be written as c1i plus c2j plus c3k. If A and B are any two vectors, then we can also denote vector A is equal to a1i plus a2j plus a3k, and similarly vector B can also be denoted as b1i plus b2j plus b3k. Suppose if C is any vector, C can also be denoted as written as c1i plus c2j plus c3k, where I, j, k are the unit vectors along x, y and z axis. Okay. Now let us come to the next concept, that is the addition and subtraction. Suppose if A and B, that is what I will explain in this line. If A and B are any two vectors, then if A is equal to a1i plus a2j plus a3k, and if B is equal to vector B is equal to b1i plus b2j plus b3k, then the sum addition of two vectors A plus B is given by, add this a1i plus a2j plus a3k plus b1i plus b2j plus b3k can be written as coefficients of I. Coefficient of I is a1 plus b1 into I plus coefficient of j a2 plus b2 into j plus coefficient of k a3 plus b3 into k. So a1 plus b1i plus a2 plus b2j plus a3 plus b3. Coefficient of I, coefficient of j and coefficient of k can be added separately, whereas the difference, the subtraction a minus b, subtract this a1 minus b1 into I plus a2 minus b2 into j plus a3 minus b3 into k. So just the coefficients of I, j and k must be added or subtracted to get the sum or the difference a plus b and a minus b. Now there are few properties of vectors. These are very important properties. K into vector A plus B, so is always equal to K into vector A plus K into vector B, where K is a constant. That means if you multiply any vector by a constant, then multiply the whole vector by that constant K. K, or if sum or difference of any two vectors are multiplied by a constant K, then you can multiply the individual vector by that constant K. K into vector A plus K into vector B. K into A plus B is also equal to K into vector A plus K into vector B. Suppose if it is minus, you can also take the negative sign. If it is minus, K into vector A minus B can also be written as K into vector A minus K into vector B, where K is a constant. Second property, if K into M times vector A can also be written as, multiply these two constant, K into M vector A, K into M into vector A. If A and B are any two vectors, if they are collinear, for any two vectors, if A and B are collinear, then vector B is always equal to lambda times vector A, or A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to lambda. for the collinear vectors. Suppose if A and B are any two vectors, then vector B is equal to lambda times vector A. This is the property we are using to prove that the given vectors are collinear. Or A1, the ratios A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to a constant lambda, then it is called a collinear vector. Or that is, if B is equal to lambda into A, means for these two vectors I can write B1 is equal to lambda into vector A1, B2 is also equal to lambda into vector A2, B3 is equal to lambda into vector A3, then this implies B1 divided by A1 is equal to B2 by A2 is equal to B3 by A3 is equal to lambda. Then only you can say that these lines are collinear. So actually this is B1 by A1, B2 by A2, B3 by A3. So this is B1 by A1 is equal to B2 by A2 is equal to B1, B2, B3 by A3 is equal to lambda. B1, B2, this is B3 by A3. B1. So otherwise I will strike this. B1 by A1 is equal to B2 by A2 is equal to B3 by A3 is equal to lambda. Then the lines are collinear. Okay. Now let us come to the next simple problems. Now let us consider a small example. Find the values of x, y and z so that the vectors vector A is equal to xi plus 2j plus zk and vector B is equal to 2i plus yj plus k are equal. Now according to the definition, the equality of the vectors, two vectors A and B are said to be equal if and only if their corresponding values, the coefficient of I, j and k are equal. So here what is vector A? Vector A is xi plus 2j plus zk is equal to vector B 2i plus yj plus k. This is equal if and only if the value of x is equal to the coefficient of I. Coefficient of I here is x, the coefficient of I is 2, x is equal to 2. And the coefficient of j is 2, coefficient of j is y, y is equal to 2. And z, the coefficient of z, k is 1. So if and only if x is equal to 2, y is equal to 2 and z is equal to 1, then the two vectors are said to be equal. So for these values of x is 2, y is 2, z is 1, the vector A and B are equal. The values of x, y, z are 2 and 1. Now let us come to this problem. If A is equal to I plus 2j, B is equal to 2i plus j, if vector A is equal to vector B, then if these two are equal, if vector length of A is equal to length of B, are the vectors equal in this case? See here, what is the problem? I is given, j is given. If the lengths are equal, are these two vectors equal? Let us check what is the length of A. Length of A is equal to root of x square, 1 square plus 2 square. That is root of 1 plus 4 is root 5. Length of A is root 5. Similarly, length of B is equal to root of 2 square is 4 plus 1. This is equal to root 5. So, length of A is equal to length of B. The lengths are equal, but the vectors A and B are not equal. But vector A is not equal to vector B. The reason is because the coefficient of I and the coefficient of I in these two cases are not equal. The coefficient of I is 1, here the coefficient of I is 2. And the coefficient of j is 2 and the coefficient of j is 1. So, these two are not equal because the coefficients of I and j are not same. These are not equal because coefficients of I and j, coefficients of vector I and j are not equal. So these two vectors are not equal, but their magnitude are same, but they are not equal vector, as the coefficient of I and j are not equal. Okay, these are few examples for equality of vectors. So that is regarding the definition and the types of vectors and the properties of vectors. That's regarding today's session. In the next class, I am going to discuss regarding the operations of vectors, that is addition, subtraction and the scalar multiplication, that is called as the dot product of vectors. So that's regarding today's session. Let us meet in the next class. Thank you.